called analog engineers. The word analog means not digital for all of you guys. That was my first DEF CON and my first beer. And I made 50 cents to fix neighbors' televisions because they were not smart enough to take off the back, remove the tubes, go down to the drugstore, replace them. And 50 cents a TV for a 6-year-old, that's a lot of money back in those days. And they thought I was really smart. It was, no, I just wasn't smart enough not to touch the rings around the CRT, which would knock you senseless. This is what an electronics store for us, when we wanted to build something, we'd have to go through there and find all the little bits. We could not go to Amazon and order the damn kit. That was the first computer I ever built, and it was an analog computer, meaning not digital. We're going to get into some of that a little later. That was my high school computer, and I began to discover that I'm a shitty programmer. Oh my God, was I bad? So high school and I did not really get along very well, and I decided I was going to go become a research scientist at Bell Labs without a high school diploma. Actually, it went pretty well. The interviews went well. And then there was one final question at the end of it. And over on the left is what telephone wires used to look like in the 60s. 2,048 pair. And the HR lady holds up one and says, "What color is it?" I'm colorblind. And in those days, that was sufficient for me not to be able to get a job at the telephone company. So across the street was the second best company in the world, IBM, and I went in and still no high school diploma, but I took all the tests and, okay, you're good. Yeah, we want you, kid, and we'll train you and we'll pay for college and all of this stuff. Only one thing. See, I had hair down to here. They wanted me to look like Ross Perot. I was 16, and that was just not going to happen. So I went into the family business. And my father produced Dylan, Peter, Paul, and Mary. My mother had a studio at home. So I grew up in all this stuff. And something happened when I was 16 years old and I went there. I realized that as soon as I saw this, I understood exactly how it all worked. It just came natively to me. Not saying that's smarter. It's just one of those peculiar things. I understand systems. And so I worked in the record industry for many, many years. Anybody recognize what this is? You know what a lathe is? Because it says it. Well, what's the word up there? Lathe. Very good. This is how we used to make records. That's the turntable, analog electronics from the audio source, and we would cut a master with a diamond tip, which would then go to a pressing plant and produce vinyl records. This was the kind of technology that I grew up with. Then, anybody know what that is on the right? What? Patchboard. No. It's Robert Moog's first synthesizer. And I worked at Electric Ladyland with Hendrix, and that was their the first one that was really put into production. And again, it was a system that I just kind of understood. Then I said, oh, I'm going to go do some computer stuff, built one of these things, machine language programming, and I think I said I suck at programming. But I was good at audio and video, and this is how we used to synchronize audio and video for TVs or shows or movies. And when it worked pretty darn well. However, like everything we've seen earlier today, sometimes things don't go so well. So we would have to go into manual override. Anybody know what that is called on the upper left? It's called a Lissajous pattern. And you can get that pattern when you manually adjust the speed of hysteresis-synchronous motors so that they're running at the same speed. We had to do that by hand for TV shows when shit broke. Again, I came from a very different background. This was the first, I had 32K of RAM. And I wrote a database, it sort of kind of worked, and it ran on a cassette. Anybody, a few of you gray hair got to go back and remember some of this. And I said, I'm no good at this. Then the audio industry said, we're going to go digital, and we're going to automate everything. Well, the $150,000 later, I met my wife at this company, and that thing never worked. But it was the first attempt at trying to bring digital into the analog world. That was me doing mixing old school analog period. That's the only thing I really cared about. And then I decided, after leaving the music business, I was going to become a security expert. Just the next day. So January 7th, 83. Anybody recognize what that is over there on the right? Orange Book. Orange Book. And that was only thing that existed in those days when it came to referencing how to build a secure system, allegedly, but not. Because that was designed for standalone, single-user, mainframes hidden in a SCIF-secured facility with guards protecting it, not for networking. Subsequently, after this, came out the Red Book, and the Red Book was the trusted network interpretation of the Orange Book, which said, fundamentally, after 900 pages, we have no earthly idea how to secure a network. And that's sort of where we are today. So in the early days, I started picking up some security stuff and decided, wow, you know, the internet could be weaponized. And I started writing about the weaponization of technology. And it came from just some ideas I'd had about how systems work and how they would glue together, and then can you make it evil? And it turns out, obviously, now we know we can. And I actually told Congress about all of this in 1991, and the Congressman Glickman said to me, Mr. Schwartau, can you please explain to the committee why the bad guys would ever want to use the internet? And that was the foundation of information warfare, cyber war, and all the stuff that I spent a lot of years doing. And the whole goal was, how are we going to win what's going to be coming down the line, the kind of stuff that we're seeing today? So certain things evolved over the years, and I wanted to prove security could be done. That was really kind of my personal goal, and it has not been done yet, but I'm going to show you a crash commercial plug a little bit later about some ideas that we've got on this. So that is where I came from. That's a little fast history of the security industry. However, today, shit's still broken. And we need to start taking a different look at cybersecurity education. And a lot of the skill sets that are needed are in this room, but they're not in what we're training. In security, there's three ways of looking at it. You have the cyber domain, and we all kind of, okay, that's cool. But then you have Chris Hednagi, social engineering, you have the human domain. But of course, we have the physical domain, and many of us have lived through the stovepiping in enterprises, that the physical guys aren't going to talk to the cyber guys, and they're certainly never going to talk to the HR people. Why the hell would they do any of that? And so we have this complete disconnect historically. It's finally starting to come together. However, I had a talk with Janet Napolitano. She said at RSA, we cannot find enough cybersecurity people, and middle of the thing, I yelled out, bullshit! What you can't find are perfect people who have the kind of education that you're demanding. All the artificial specifications, my color blindness from 30 years or 40 years earlier, my refusal to cut my hair to look like Ross Perot. Arbitrary discriminators are what is happening throughout our field, whether it's with the government or whether it's with enterprise, trying to get some people who, let's say, are on the spectrum, getting them into organizations to actually accomplish something is often way too hard, with very, very few exceptions to that. So we have all of these types of arbitrary discriminators that are already causing problems, and then we have the additional anti-discriminator that says, if you don't have a bachelor's, can't hire you. If you don't have a CISSP, can't hire you. If you don't have an MA, and on and on and on. And these are all checkbox compliance things that are saying, do you know how to configure a firewall? Okay, you're hired. Can you spell Wi-Fi? You're hired. And we're not looking at the bigger picture of security and treating it as a systemic environment. So I look at all of these security problems, and I fundamentally believe that they are all identical. They're just different manifestations of the bad guys doing bad guy stuff on the internet, or poor configurations. And when we look at them all, they have one underlying feature. Every single one of them can live in the time domain. Physical security can live in the time domain. Human security can live in the time domain. How long does it take to social engineer somebody? Chris has been doing that for years. And in the cyber domain, we're starting to look at detection time and reaction time a lot more. So these are all the same. But we, in my opinion, are leaving out 3 core skill sets. And one of the reasons that we're in the mess we're in is because we're not looking at security as a discipline that is actually more interdisciplinary than the way we as an industry are treating it. So we need some new ways of thinking. And the first one is engineering. When you get a job at any organization, does the HR person ask you, how many times have you failed? How many times have you royally screwed it up? They don't want to hear about that. They want to hear about that everything you've done is always perfect. But in the engineering world, it's exactly the opposite. We thrive on failure because it teaches us great numbers of things. And for those of you that write code, you got to do it again, and do it again, and do it again. And debugging it is for a reason. But we do not embrace failure. We do not teach the fundamentals of logic. Anybody know what this, I'm colorblind, goldish orange thing is down there? It's going to change your lives in 10 years. It's called a memristor. And it can hold up to, right now, 10 individual bits of information passively with no power source. That's going to change things very, very radically. It was theorized in the 1970s, and in 2009, HP actually proved proof of concept, and it works. We're not teaching enough of the basics of logic of systems. We're teaching programming, we're teaching Python, these things, and don't forget, you have to have the CISSP in order to get anything done. We are moving into a cyberkinetic world more than ever. But what about the physical engineering aspects? Do any people in any of the cyber universities, do we teach this? No. Very, very isolated cases do we see it. What caused that bridge to collapse? How does the stress load of robots and the programming of it and the cyberkinetic relationships, how do they interact with each other? I'm not saying we all have to be full-on engineers, but some basis of understanding of the way that the other systems that we're building and putting together, how do they behave, and what are some of the fundamental rules that are associated with them? Electricity 101. That's it. You don't have to become an electrical engineer to understand some of the basics. Analog, that's the world I grew up in. And we're going to be getting more and more analog as we're using actuators and the cyberkinetic systems that are going to be much more server-oriented, but it's server motor versus our kind of server. So we've got to kind of get some of the language straight there, too. The use of feedback is mission critical in every single electrical circuit, mechanical system ever devised. Can anybody tell me how much feedback education you've ever received in cybersecurity? I got a 0. I got shaking heads. Feedback creates stability in a system. If you have no feedback, you tend towards infinity. When you start tending towards infinity, what happens to your system? Fails. Absolutely. And yet we're not doing it. SCADA systems. Study and learn a little bit about ICS and SCADA when you're taking your first courses. Because those systems, the ones that run all critical infrastructure around the world, those are the ones that actually use feedback. They sense all of the environments and then start trying to build a system that will remain stable under external influences. And one of the biggest ones in the world, just in case you care, is the dike system in Holland. In 1953, 40% of the country flooded with a 500-year storm. And within 30 days, they had a plan. The government actually made something work, and their dike system now is completely automated and saves the country from the 1,000-year storms. How much of the small stuff do we teach? Do we teach kids or professionals in universities? DNA memory. It's going to change things. It's going to change the world. How does optical systems, how is that going to affect things? What about the security of bionics? Do we give enough basics of how these systems work? And I argue, no. Don't become fluent in them. You don't have to, but you have to become conversational if it's going to become a system that has any integrity whatsoever. Probability, more and more as we get especially involved with artificial intelligence, machine learning, deep learning, all of those words, probability 101. This is going to become a probabilistic industry in the very, very near future. The binary answers will not exist. So understanding how probability works is going to be mission critical in the education for the next generation of kids coming along, and perhaps for some folks here as well. How are the quantums going to affect things? We don't know all those answers yet, but again, those things need to be part of a curriculum to give the basics of where things are today. Understanding how neural networks work. Don't have to become a neural programmer, but understanding how they work to the limited extent that we do know how they work, because fundamentally anybody who's in the AI business professionally knows it's a guess. It's a pure guess. And how does biasing affect things, and how does the brain connect to it? So all of these issues are now being claimed by many vendors to say, oh, ours is going to take care of all your security problems. No, it's not, because you don't know how it works any more than the AI experts do. Fractals, multi-dimensions. When you're dealing with databases, how does the fractalized data parse out? Do we teach any of this? Unfortunately, not much. And then obviously we have to worry about exoplanetary affairs. Anybody know what the Carrington effect is? What is it? Stand up and shout it out. Yep. Now, it's called the CME, coronal mass ejection. If one of those hits the planet today, what happens? Oh, you guys are pleasant. There are some techniques, a way we have 72 hours notice. If one is coming to us, there's a couple of ways to save the planet, but it's going to require some planetary cooperation, and I've not seen that happen yet. And again, how do all of these things affect the systems that we are building? The second thing that we don't teach enough of at all is history. Fundamental history. That's why we're making the same damn mistakes over and over and over and over again. When in June 2007, what event changed the world? This is a history question. Want me to rephrase it? The iPhone changed the world. How did it affect security? The same old shit. We had not learned anything from the last 45 years, from the first security model in 1972, done by Anderson, didn't plan for security. And now we've got IoTs and all these other systems I'm talking about. We haven't learned about history. And some of these people have made great mistakes, and we can learn from those mistakes. And again, I'm arguing we should be part of a fundamental cybersecurity curriculum at all levels. You don't have to become a history major to know anybody know who that stupid kid on the left is? No, neither do I, just some stupid kid. But all of these people made tremendous, tremendous errors. Anybody know this lady's big error and contribution? Bug, exactly. That's Admiral Grace Hopper, who coined the term bug when moths used to get into computers and shut them down. Oh, there must be a bug in the damn thing. And that's where it's come. Again, understanding the history of the technology, of all the technologies, because we're reinventing the future, hopefully not based upon exclusively past mistakes. Do we teach the computing history that goes back thousands of years? Cryptography that goes back to the days of Caesar, using simple ciphers that worked effectively, the Antikythera machine. All of these have contributions to be made when we're looking at new problems through different prisms. And one of those prisms is history. Looking back, how much information theory was taught in anybody's cybersecurity education? 1, 2. Information theories, that's what we do. But you got to have a CISSP to get the damn job. Information theory be damned, and that's the basis of everything we're doing. Does anybody know what the von Neumann bottleneck is? All right, the von Neumann bottleneck is the speed difference between processing on a chip and the bus transfer speed on the motherboard. And it limits Moore's law. Why aren't we teaching this as fundamental concepts of what's the world that we're dealing with here? If you've never studied Norbert Wiener or Kurzweil's work, gives you different perspectives on the current problems that we've got today through eyes of history. Computer security history. That I bet most of you didn't know, the computer industry was dominated by women until 1984. They ran everything. Anybody know the ladies on the upper left? There was a big movie about it recently. Yeah, they're mathematicians that got the Apollo program working. This is Grace Hopper down here. Anybody know what the center machine is? What? The Bomba. And it was all run by women. Something went wrong, and we need to redo part of that balance, and we don't know it unless we study a little bit of history. Military history. Why the hell would you need to know some of that? Well, deception. A lot of vendors that are doing deception, finally, because it's a valuable technique in the arsenal. The old the War Magicians, Benedict Cumberbatch, he has a new movie coming out that's about the War Magicians from World War I and World War II that used deception techniques in order to hide D-Day invasion, or to make it look like there were 30,000 tanks actually in the desert and there were none. Similar to what we're doing conceptually, but we're still not teaching enough of this. Massification, the concept of how, in DDoS terms, that is massification. And it's an old Clausewitzian, Roman, Napoleonic warfare technique. But we don't look at much of our security industry through that particular prism. Anybody know who John Boyd is? John Boyd. He was a military guy, colonel in the Air Force, and he designed a thing called the OODA loop. And the OODA loop is about how do I beat my adversary? And when you're up in a dogfight in the sky, you really don't want to lose that battle. You really want to win it. And he formalized a mechanism that we're now starting, and I'll show you the crash commercial pitch later, that employs the same technique that we used in MAD, Mutual Assured Destruction. Once we detect a Russian launch, we got 19 minutes to decide what to do. And it's all part of the OODA loop work, because OODA loops are all about feedback. And fundamentally, it's detection, observation of your situation, and then you're going to orient it. How does that fit into everything else in my environment? To make a decision as to what to do and then act upon it. So it's a detection-reaction system that is a process, that is an iterative process over and over and over again, like an ICS system, like a SCADA system, yet we're not looking at applying these types of techniques through the prism of 6,000 years of history. Is it going to work everywhere? I don't know. Is it worth considering? Yeah. Everything should be on the table, especially because the way shit is so broken right now. The answer to this all is, in the case of a dogfight, if you can get inside of your adversary's OODA loop, you win. Really a very fundamental, simple concept that can apply to network defense, if we think about it, and I'll show you a couple ideas on that later. I promised you some porn. There's porn. All right, everybody's had enough porn. The third area that we don't teach is part of core cybersecurity curriculum is humanity. Humanity. And I chose that word instead of social engineering for lots of reasons that you'll see. But right now, what we have been trying to do since the digital age came in is how can we make people be nice and talk to computers and we'll live their way, versus trying to get the technology to be more human in its behavior. Why should we have to change? And that is something we've been doing now since arguably 1950. Combining great engineering, combining that with endeavors, combining that with the human element creates massive amounts of opportunity when your culture and your educational background gives you that opportunity to do that. Start with the concept, what is this? What is humanity about? Right now, the best neuroscience answer is the brain does only two things. It senses its environment and predicts the future. Now, that future could be one heartbeat. It could be a few milliseconds of neurons processing. It could be 700 milliseconds from the time something sweet is on your tongue to the time it registers in your brain. We have all of these data. We understand this data, yet we're not applying this kind of thinking to the way we view the three elements of security: the physical, the cyber, and the human. Psychology. Users, humans, executives, geeks, we all screw up. But why don't we understand more in the cybersecurity community how to design systems that work in concert with the psychology that is inherent as us as humans are failures? Why do we ignore that? Why is that not part and parcel of everything that how the human is supposed to react? You know who understands this one really, really well? Anybody? What industry gets this really well? Marketing, they solve all problems, right? The gaming industry. The gaming industry. They know the key word there, and that's addiction. They understand it. Why aren't we thinking about that in our field? I don't know. We understand how all the senses work, and what we've been doing as an industry for umpteen years is defense in depth. Let's add another firewall. Oh, no, wait a minute, that one sucks. Let's add a next generation firewall. That'll fix it. And if that one does it, the next generation one will fix it. And that's what we're doing. So I argue that why aren't we doing detection in depth? Because that's what the rest of the real world does. This is a GE engine. It's the one that we all, road warriors, we trust our lives to General Electric. Inside of this, it's model 900X. There are 5,000 sensor points updated every single second. When we look at that in terms of the way I described the brain, what's it doing? It's sensing its environment in order to predict the future. Because you want to know damn well far ahead of time if you're going to be having an engine problem. We're doing it in the physical world. Why aren't we teaching these concepts to new generations in the educational system so they can look at the problems that we've got under a different guise? Humans do an amazing job of filtering. I don't know about you, but apparently on Facebook, there's a lot of ads. I don't see them. How many of you are blind to ads? All right, some number of, this is all part of a psychological training thing you can actually go through and learn how not to see them. And for me, it's just because of my idiot focus ADHD kind of thing, or OCD, or MOUSE, whatever it is I got wrong. But we know how to filter brains really, really well, but we have not applied that thinking yet. And we're just beginning to with AI/ML in terms of advertising and human reaction. The brain is amazingly plastic. You can survive on just half a brain. If you have a brain injury, it will automatically reconfigure its networks and different neurons will take over the functioning of other neurons that may be damaged. It's all completely automatic. What, are you going to have some downtime? Yeah, sure. There's going to be some problems? Yeah, sure. It's never going to be perfect because it's on an analog spectrum. The closest that we have to this kind of work is now being developed conceptually by DARPA to having what they call self-resilient networking. But it's way early, and I would argue that it should be done at the code level versus the networking level first. But again, the concept of building something that is plastic and adaptable to its environment in real time is something that we as an industry have failed at. Perception. I see very strange colors. When I hear music, I can see the music dancing in patterns. It's synesthesia. We all have different levels of perception. What we need is more people in our industry trained with different levels of perception to have different viewpoints and look at it instead of the very binary, arbitrary discriminators that I talked about earlier. Does this bother anybody, that image? Show of hands if it bothers you. All right, this is about right. 5% of my audiences look at it. I can't look at it because I start tilting over. 5% of people, this messes with their heads. How does that affect cybersecurity? I have no idea, but I do know that we are trying to deal with human beings interacting with a lot of visual stimuli. You may remember a few years ago, a whole mess of kids in Japan allegedly had epileptic fits because of the synchronization signals in one video game. Let's just take these things into consideration. Multidimensional views. If you've never read Flatland by John Abbott, written in 1882, it's about a two-dimensional civilization that interacts with a three-dimensional civilization and how they perceive each other differently. And then there's the follow-up books where there's a 3D civilization talking to a 4D civilization, and there's a whole series of these that are very enlightening. But again, we're not teaching kids or professionals to look at things in different dimensions, and this ties back to engineering fractals. It's a different way of looking at it, instead of the engineering viewpoint, looking at it through the humanities standpoint. Influence. We as geeks, we as engineers are supposed to be able to influence people to modify their behavior. Chris Hednagi, social engineering. We all are trying to get users not to get snackered by any of the techniques on the phone, on text, SMS, live interactions. We all teach that. But what we don't teach is how do we get our community to be able to communicate to others that don't speak our language. Well, somebody would say, I'll bring in marketing for that. Well, that's another next generation piece of shit coming. Sorry, I'm just not in favor of the next generation of crap. But we got to learn how to do this. I remember my mother told me when, I guess I was 5 or 6, she taught me social engineering, even though we had no idea what it meant at the time. And her advice was, when you go somewhere, act like you own it. Own the space around you. And when you do that, you get access, different things happen, people treat you. And now we all know this from social engineering. And again, I got this as life lessons from my mother, a former record engineer with NBC. We got to get the communication skills up in geek schools so that they can put together that influencing presentation, that influencing mechanism. One of the problems that exists with writers, with movies, with bad drama, bad comedy, is that they try to tell a story versus show a story. When you're reading a book, if you don't have visuals immediately going on in your mind, they're telling a story, they're not showing a story. In order to communicate, especially in today's hyper-fast multimedia environment, we have to, as a community, be able to communicate to all sorts of different audiences and keep some very specific things in mind. Positive feedback is about training and education. Anybody know what the 70-20-10 rule is? 70% through experience, 20% through visual, and 10% through reading is how people retain information. The 7-second rule. Anybody? What? 7-second rule is the attention span of the average human today. 7 seconds. Do we design our systems, our interfaces, to be able to reflect how well gaming industry does with addiction, so that we can, how do we get our users to behave in different ways? The 2.2-second rule. In the old days, we used to have a thing that some of you may remember called magazines. And you turn the pages, and the rule of thumb is advertisers were given 2.2 seconds in order to capture the attention of a reader. These were well-known facts from the advertising industry. Advertising industry knows the psychology of its customers perhaps better than anybody. Very different than marketing people, because those are translating bullshit. The advertising people, they have hard data to be able to back this stuff up. Ebbinghaus forgetting curve. Anybody know what that is? The forgetting curve. The work was done by psychologists in the 1880s, and it still holds up. That once you've learned something, unless you have repetitive, OODA-loop style repetition and reiteration of it, you will have down to 5% retention in 30 days. And there is a complete exponential fall-off curve that has held up under modern studies as well. So when we're talking about humanity and people and those that are using all this technology, we're not teaching any of the basics of how the system between the human and the engineering system needs to work. So these are all about applying another triad, trying to get engineering, history, and humanity into our field so that we can create perhaps some new answers, some new ways to be able to think about the problems that we have unfortunately been thinking about in the same old way. Now here comes the bribery. I wrote a new book. And whoever asks the best question gets a free copy. So that's bribery too, isn't it? That's a troll. I recognize the difference. So there's the book, and it's taking a look at security through a completely different prism of some of the things I've talked about here. It's trying to give a fundamental curriculum outline in many ways of the things that are not taught in cybersecurity, and then trying to get them to apply with some new ideas and to make them come up with different answers. So it's really, really pretty. It's a steampunk book. But for example, we know how to measure, every user can measure the performance of their security at home. I'm sorry, of their network at home. Can we measure security? We think so. We think we figured out an answer to do it using the schematic on the left, and then the book is full of schematics. But there is a way to actually measure security that duplicates how we do it in the physical world. In the physical world, it's really pretty simple. How secure is a pane of glass that protects $1 million of diamonds in a store on 47th Street in New York? Not much is the right answer. But what do we care about? We care about the response. In that case, it's a detection response, time-based mechanism. So in the physical world, we understand this. Does anybody in the room know exactly how fast their particular IDS, IPS, whatever, device operates with what degree of efficacy? Or do you trust the salesman? Oh, that's a good answer. You know, it doesn't get you a book, but I know that's the problem. So we have some ideas, taking all that stuff I've been talking about earlier on how to actually quantify security. And we have some math behind it as well. This is what happens when we have like two IDSs. If you hook them up in one way, you're going to increase your efficacy by 2 orders of magnitude. If you hook them up the wrong way, you're going to decrease the whole point. It's useless to even do it. And we show exactly how to do this with mathematics. You want to stop fishing? The schematics, we give them away. This is called the time-based SMTP ass saver. Now, I am not productizing any of this at all. This is a book with the ideas that came out from all this educational thing. And basically what it does is it stops data exfiltration of stuff that you don't want to leave your company that can all be set by policy, and it can be proven mathematically to work. These schematics solve DOS, DDoS, spam, identify infected devices from Mom, Pa, and Granny and all of that. And again, this is all by looking at the universe through some of these prisms I've been talking about. There is the formulas for security. They actually work. In the upper right is what security looks like when you're combining various types of curves, decays, trust factors, and all of the combining of the engineering, some of the physical, understanding the history and eliminating the shit that doesn't work, that we know doesn't work, but the next generation box will fix, I'm sure, and tying them all together and just trying to come up with some different answers. And some of the math gets a little bit tough, but fundamentally it is not all that difficult, and you need nothing more than basic algebra to be able to design a system using any of these techniques at all. So that's the high level view of where I came from, how I view the universe differently than you, and a lot of people, and where I think I've been able to find inspiration from different disciplines over the years, and that I think they need to be shared as part of our educational curriculum and process in order to get us out of the shithole that we're in right now. So thank you very much, and I'd be happy to answer any questions, and the best question gets a book. Thank you. Wow, I'm on time. Question? Yes, sir. Yeah, you with the pointing at your own shoulder.
Concept of adjusting the mindset of existing security professionals, but in my line of work, I work for a nonprofit. I have to help educate like middle school and high school kids. How would you address these concepts and work it into a curriculum, either in their standard education or into an extracurricular setting?
I remember 20 years ago, they say, we have these computers and now we're expected to build them into the curriculum. How do we do it? The educators, I don't know the answer to that because I'm not a professional educator. I'm a security guy who looks at the world differently. I think that the professional educators need to be the ones to help us make that transition or some of the inculcation of the various ideas into the curriculum. My focus on this has really been more at the cybersecurity professional level, university level. I fully agree we got to do more to the kids, and it is going, the answer, if I believe my own bullshit at all, is going to be through some form of iterative, reward-based gamification approach. Would be my gut reaction. Yes?
Aren't you just getting back to what education used to be?
Aren't I getting back to what education used to be? Interdisciplinary, well-rounded. I think they it's amazing when you talk to a Brit that they can quote Shakespeare, and you can't. It needs to be much more well-rounded than what we're doing because we have become entirely too verticalized. And I'm just talking about our field. I'm not going to take on the whole system, but in our field, we've become so incredibly verticalized with our skill sets that it's the forest and the trees. Yes, and the black hat.
So understanding that it is disciplines, and most cybersecurity programs are driven out of the College of Science and Mathematics, or the College of Business, or the College of Computer Science and Engineering. Like, how do you, as a non-educator, how do you see actually, and understanding the politics of higher education, like how do you bind those colleges together that are ultimately competing for money inside of higher education to form a cohesive degree that will be valuable to the industry?
You remember in high school, I don't know if they still do, but there was a thing called General Science 101, something like that, and it was supposed to give a broad brush, 2 semesters of here's science, now go physics or go something else, whatever. We also have a thing in school called Geography 101 and History 101. I'm really looking at the concept of an Engineering Technology 101, a History 101, Human, what are we about 101. I'm not trying to redesign an entire curriculum or make everybody experts at stuff. It's just get some of these things into your heads and you'll see the world slightly differently. That's my kind of vision for it. I'm not an educator, but being able to have people be conversant in some of these issues and related to cybersecurity versus the deer in the headlights, which I often run into, and that's, again, crass plug for the book. I describe all of these technologies and approaches in order to get people the ability to 2 minutes. I started 3 minutes late. Bullshit. Yes, sir.
I see the big picture of this, and I really like it, but trying to focus so it doesn't just fade into the ether when I walk out of here. If you were looking at something for master's programs for cybersecurity, what would be 3 to 5 things that you would see in a program and say, this one might not be total bullshit, this might actually be something?
Well, that's why I brought them down to 3. Engineering, teach basic fundamental engineering, because most engineering disciplines are the same. You just have to, what environment are you in? It's getting fundamental concepts down. That's why engineering, the history of it and where it's going, what's the cutting edge. Then the number 2 is the history of technology, and then the humanity. I broke it down to 3, not more than that. I tend to like working in 3s for lots of reasons, but that's a whole different talk. Yes, sir.
Yeah, so from the business side of things, how do we convince our corporate managers to pay more attention to a broader skill set rather than somebody who can hammer on one piece of software? And also, where can we buy your book?
Okay, I'll answer the second question. No. I wish I knew that answer. I think it's going to be like everything else in this community. A few of us are going to start hammering, and there'll be some, like autism. Some people on the autistic scale, we need those people desperately to find that semicolon in 20,000 codes of line. Hey, go find it. I'll see you in a week. And they're good with that because that is their skill set. Yet, how many companies actively seek out that kind of skill? And there's a very small handful of them. And it's going to be the same sort of problem. Going back to the arbitrary discriminator stuff that I talked about when I was a kid and the same things that we have today. We're going to start beating on folks. I think the biggest thing that could come out of this perhaps would be a couple vendors that see some change and put it into people's hands. The gaming industry became addictive very, very quickly. I mean, I still, 8-bit's the only thing I like playing. They understand this, and they monetize it. How do we do this? I'm not really good talking to C-suite people. I saw another hand. Yes.